Okay, now we're going to go into my second favorite practice, which is permeable pavements. So what is a permeable pavement? Well, it says it in the name. It's a paved surface that allows infiltration and treatment and storage of stormwater. It allows water to go through it instead of piling up at the surface and running off. It can be designed to accommodate pedestrian, bicycle, and auto traffic. So porous asphalt or warm mix asphalt pavement is called porous asphalt. That's because there's actually an industry group that has said porous asphalt is what they want to use. Pervious, Portland cement concrete, kind of popcorny. They use the term pervious for that surface material. Permeable interlocking concrete pavers, those are the types of pavers you see from like Mutual Materials and other suppliers out there that are paver systems that have gaps between them and sand so that it allows the water to filter through it. And then the final category is kind of grid systems that are made of concrete or plastic, and infilling into those you could either put grass or gravels into those. Permeable pavement really refers to the full system because it's not just about those surface materials. That's kind of what we call each of those surface materials, but the whole system is a permeable pavement system because that's what's really key is the whole system, not just what you're putting at the surface. Again, this is porous asphalt versus pervious concrete. That's kind of the lexicon that's out there in terms of terminology. Here's some pictures of permeable interlocking concrete pavers. Again, they're paver systems with gaps in them. And then you have these reinforced grass or gravel systems that are basically like these little plastic cups that provide that spread loads and provide a hard surface while still allowing the infill material like gravel or grass to not become compacted. That's really what those systems are about. And those are for much more low use type applications, but much lower cost. The wearing course is that pervious concrete, porous asphalt. That is that surface material that you're actually running traffic on. But beneath that, oftentimes because you're dealing with it, you have to construct that surface, you need to have a bedding course, which is a finer grained material that allows and doesn't roll around on the equipment during construction. And that's what separates the wearing course with the reservoir course or the base course, which is where you're storing the actual water. So you actually have a much more larger gradation, much more open and uniform gradation, so you have pore space in there to store the runoff. And again, the reason for that is if oftentimes it could be like marbles for the construction crews to be working on that, and it's not a good surface for laying down that wearing course, so that's why you need that bedding course on top of it. And then you have to really consider that the subgrade is a very key element of these practices. It's got to infiltrate into the soils. That's really what's providing the water quality treatment and, in the end, the infiltration. Really, what we're doing with permeable pavements is providing that window for that runoff to get down to those surfaces. You'll see some guidance out there that recommends geotextiles. I think that's a very risky item, actually, in honesty, because that's usually what plugs up in those systems, because it's usually a finer fabric where it gets plugged up. And if it gets plugged up, you have to rebuild the entire system. So another option there is, again, another gradation of aggregate there to keep the subgrade from pumping and coming into that storage reservoir course. But that provides a better surface area that wouldn't plug up as much as the geotextiles. But in some areas, especially in soft soils, you're going to need a geotextile as much as anything for additional support to spread that load across that native soil so you can actually get that system to actually carry loads. Other aspects, subsurface berms. So if you have this system on a slope, water will preferentially kind of filter through all of this porous aggregate and porous surface material and try to run along that native soil surface. So that can reduce your infiltration area and cause potential erosion down there. So you often want to put in a subsurface berm if you have anything greater than like a 2% slope on those pavements, because you want that water to preferentially pond a little bit in that storage zone and get into the native soils. Benefits of it, it reduces your impervious area. So if you have a porous surface, then it's not something you need to manage anymore. And that's why I like this practice so much, because it doesn't take any additional footprint. So it may be a little bit higher cost initially, but you're not building any additional infrastructure to convey the runoff, to retain the runoff and treat the runoff. It's all doing it right there at the site. The area that's reserved for vehicular traffic, especially on commercial sites, is nearly 2 times the building area. So that's a real big opportunity area to try to reduce impervious surface on your site. It reduces peak flow and flow duration, again, because you're infiltrating the runoff. Also, you're slowing the runoff down because you're not creating this efficient paved surface that's immediately conveying runoff to the downstream system. It mitigates habitat and degradation of streams and wetlands, reducing the volume, reducing the temperature of the runoff. And it can be an effective solution in cold weather and arid climates, but it can handle a wide variety of climate conditions. Applications. Industrial sites, probably don't want to put it on an industrial site itself due to the pollutant considerations, but in the employee parking is a very suitable application. Commercial parking, Sidewalks, you see a lot of applications in sidewalks because you're not having to deal with any loads. It's a very low-hanging fruit kind of practice. Driveways, again, not high traffic areas. You might be able to use these practices for it. Residential access roads, emergency roads, and overflow parking areas. The theme here is lower use roads. They don't need to reach that high level of load carrying capacity. Those are the best opportunities for doing a porous pavement. Areas where there's limitations. I mean, you're going to see a lot of engineers be a little bit more nervous about using on a very heavy use zones. High use arterials, highways, thoroughfares, other areas with transit on it, where if it fails, you've got a big disruption of the system. And also you have a lot more load capacity there that you have to deal with. The other issue is, again, like I said, there's no treatment credit for permeable pavement. So if you're on highly infiltrative soils that are greater than 2.4 inches per hour, the only way you're going to get a permeable pavement to work is to put a treatment layer underneath. So you'll need another 18 inches of material down there to filter the runoff before it goes into the native soils. So that's generally too cost prohibitive to do that practice in those locations. Should not be used in areas where there's excessive sediment deposition. That's pretty obvious. The sediment's going to rush off to the site and plug those pores. So if you're going to have that and you're not going to have any way to stabilize those sediment zones, don't do a porous pavement there, permeable pavement system. Again, areas that have erosion hazards or they're near a steep slope, if the slope of where you're doing the paving is, 12% is actually even getting, I would even put it down to even as low as 6 or 8%. It's really hard to build those subsurface berms enough to actually retain the flow in that subsurface storage zone. Again, if there's potential for pollutant spills, gas stations, truck stops, industrial sites where there's some potential for some nasty stuff to get down there, you don't want to do a porous pavement system because you're going to have to remediate that, you're going to actually have to rebuild the pavement. Other design considerations, establishing proper snow removal and de-icing procedures. I know that's often a very key consideration for pervious pavement and it'll oftentimes considered to be a limitation. And I would say it's both a negative and a positive, really. What's good about porous pavements is that they don't ice up as much. Is because once it becomes a liquid phase, it infiltrates and gets down into the soils. And oftentimes, because you're designing the systems to infiltrate and provide storage before it infiltrates, oftentimes that surface that you're on, the native soil surface, is below the frost layer. But if you're in a heavy frost zone, you do need to extend that zone, the bottom of the porous pavement subgrade, to be below that frost level, because you don't want that freezing up down there. But snow can kind of get compacted and ground into there, and you definitely don't want to sand your sites. So that's another consideration, is how often you're going to be plowing these sites. If it's not going to be plowed very often and it's going to still receive a traffic load, it may plug up during the winter because you're compacting that snow into that zone. So you don't need to do as much de-icing, but you may need to do pretty extensive plowing to make sure that you're not just grinding material into those pore spaces throughout the winter. The test application in Pullman, and what you see there is the porous asphalt section and a conventional asphalt section beyond it. So the porous asphalt is melting and actually getting rid of that snow and ice at the surface. When they're properly installed and maintained and sanding is kept to a minimum, they've been shown to last very long. There's really great examples. University of New Hampshire has done a lot of study on permeable pavement systems in cold weather climates. So if you're very concerned with that, go to their resources. They have a lot of information about it. There's actually a porous pavement installation in Walden Pond in Pennsylvania that freezes every once in a while. It's been in place for 40 years and has not failed during that time. So typical, again, basic maintenance for permeable pavement systems. First thing is just inspecting it, reporting and data management, so different levels there. You can do it once per year or every 3 years or so. Litter and minor debris removal, again, for the aesthetics and doing that. So again, different levels of that. And then sweeping. Sweeping is really the key maintenance activity for permeable pavements. Again, you're going to need to get the materials off of it, especially leaves. Leaves and organic matter that will have the tendency to degrade and decompose over time. It gets to be a very fine material. And if you leave that on the porous pavement surface, then it is going to eventually try to plug up some of those spaces. The good news is that porous pavements initially installed handle about 20 inches per hour. We don't get that kind of intensity around here. Even in hurricanes, you don't get that kind of intensity. So it can plug up and still maintain its performance over time. And there are ways to pressure wash and vacuum and do other techniques to remediate something that has been plugged over time. There's been lots of examples out there. But obviously, you want to do your design up front and make sure that you don't have to do that. That can be expensive. So, placing in areas where there's going to be heavy leaf fall and you're not going to be blowing that leaf fall off of it is probably not the greatest siting for a permeable pavement system. Any questions about that? What the question was, how do you deal with utility patching? One resource I can point you to is Onondaga County in Syracuse, New York. They do a lot of porous pavements and they have a dig safe guidelines. So for those utilities to come back in, they have guidelines on how much permeable surface that they can replace with conventional impervious surfaces. Because again, they can handle about 200 inches per hour, so you can have a patch of conventional that can be mitigated by the adjacent porous pavement. The key there is that new patch should not be like on the curb line, because then that's your short circuit. But if it's up near the crown of the roadway, you can deal with some conventional patching and not actually put that extra burden on those utilities to trench through it, and it'll still function like a permeable pavement system. So looking through those kind of guidelines, I think general rules of thumb are like up to 20% of that surface could be replaced with an impervious material, and it'll still function so long as you're not within 2 feet of the curb line. The skill set of contractors in installing the systems, it does take a special skill and special care during construction. That's why there's actually some trainings that ecology is trying to do for contractors to get them up to speed. The challenge is getting them to those trainings. The other thing is in your specifications for the projects, requiring a pre-certification or pre-training for the supervisor or somebody on the project to have that training. But yeah, it could be a problem, and it's going to take a while to get that skill set up to where people can do it. I think another issue with the snow plowing, when you're doing a curb bulb to fit bioretention in, that could be a concern for snow plows because they have to be able to see where that curb bulb is. So that, because usually in heavy snowfall zones, they can't see where they're going. They're usually doing a little bit by feel, like running along that curb line, and you put something in their way, they're going to blast right through it. So you need to put something visual there if you're going to do a curb bulb that cues to them that they need to swerve out and to avoid that zone. And they need to have that expectation of what's there. And I'll just throw in one more point on siting. Really think about turning movements in where you're doing porous pavements. In some cases, if there's not enough sediment contact, if there's a lot of parking going on, that's where you can pluck off the subgrade or the surface of, like, especially a porous asphalt. You'll see that happen a lot more, is it'll wear quite a bit more where there's turning movements going on, because that's a lot of load. So be cognizant of how you're designing that. And again, if you redesign your system, you can have the drive aisles be porous and your parking stalls themselves where the turning is going to happen be conventional asphalt. So not the entire surface needs to be permeable for the system to work.